also. Now, oxidation, okay, you you can you can always oxidize alkene. Okay, you can always oxidize alkene, but the type of oxidation depends. Okay, the type what is going to be the product that you will get after you oxidize, they might be different. Okay, they might be different, and we will discuss more about this here. Okay, so here I have two types of alkene. Okay, I have two types of alkene, and there are two conditions, okay, where oxidation can happen. They oxidizing agents that we use in lab is going to be potassium manganate 7 acidified, and we can also have potassium dichromate 6 acidified. The color changes, okay, you need to memorize. The color changes is going to be purple, okay, it will become decolorized, okay, if there is a reaction. Purple will become colorless, okay, and then this one is going to be orange. They are going to change into green. Okay, that is going to be if, let's say, for example, there is going to be a reaction, and of course this color change will happen, okay, when you do this reaction with alkene, because alkene can be oxidized. Now the conditions will be slightly different if you use them under cold condition and you are using them in dilute form. Okay, it means potassium manganate, potassium dichromate, they are dilute. Okay, do remember both of them must be acidified. That one is the catalyst. Okay, but in dilute form and cold condition, you are going to get different product. And we can also have hot condition and concentrated form. Okay, you are going to get different form. The easiest way to remember, okay, this is going to be the one, the cold and dilute. Why? The cold and dilute, okay, how do they oxidize? Very simple. The double bond is going to be broken. Okay, the double bond is going to be broken, and no need to think about anything. Just put, okay, the new bonds that they are going to form is going to be, just put OH and OH. This is what we call as diol. Okay, this is going to be diol. The same thing applies to any kind of alkene. Okay, any kind of alkene, they are going to give you diol. Doesn't matter the type of alkene and so on. So again, if I want to draw for this, okay, when you react with cold condition and dilute, okay, so you are going to get, okay, the same thing here. You just break the double bond and you are going to get the diol also, the OH and OH. Okay, so I'll just OH and OH. Quite simple. Okay, so the difference is, okay, if you have cold and dilute, and you are going to get a diol. Okay, that is quite simple. But the situation will be slightly different. It will be more complicated if you use, okay, hot, okay, hot and concentrated. So I will just paste the image over here. Okay, and then I think I'll paste it here. Okay, so maybe here. So I'm going to show for two examples here. Now, so the situation is going to be slightly different when we are dealing with a cold condition, okay, cold and concentrated, okay, when you do oxidation in this situation. So what happens is you need to analyze one by one. When I say analyze one by one, at the double bond, put a dotted line. At the double bond, put a dotted line. What we need to analyze over here is the carbon. Okay, look at the carbon, whether they are bonded with what. Okay, so the thing that we will look at is if the carbon bonded to two hydrogen groups, okay, or whether the carbon is bonded to one R group, or whether the carbon is bonded to two R groups. These are the things that we will notice first. Okay. So here, when I look at this side over here, I notice that the carbon is bonded to two hydrogen. If the carbon is bonded to two hydrogen, that part only, yeah, you are going to get the product of oxidation, which is going to be carbon dioxide and water. I'll write down over here. If you have that, okay, the product of oxidation is going to be carbon dioxide and water. So it means what is going to be the product that we are going to get at this side? Carbon dioxide and water. Now, how about the other side? Okay, to the right hand side, yeah. So you can see C bonded to CH3 and CH3. That is going to be two R groups, which is similar to this. If you have two R groups, okay, the product of oxidation is, okay, you just need to put C, R, and R, just put double bond O. The product of oxidation is a ketone. Okay, so I will just put it like this. The product of oxidation is a ketone. So here, how do I represent this? Okay, C, this is CH3, this is CH3. What you need to put, just put double bond and put O. So if I ask you what is going to be, if I do this oxidation for this molecule, what are the products? I will get three products. I will get carbon dioxide, I will get water, and I will get this molecule CH3, C double bond O, CH3. Okay, I just rewrite it again. So this is going to be what I'm going to get. But how about, okay, how about this molecule then? Okay. So let's try again. Okay, you see here, this carbon, when I break into two, okay, I'm going to have carbon being attached to one hydrogen and then CH3. It means this is going to be similar to this one R and one H. This one, okay, we need to be very careful. Why? Because, okay, they are going to have two steps, but we will only remember the last step, yeah. So you see, the first oxidation that is going to happen is you are going to get like what we did for ketone, carbon, one R group, one H, just put the double bond over there. That is what we are going to happen. But the reaction will not stop over there. That is going to be aldehyde. Now, this aldehyde, okay, they will be further oxidized again, which is you are going to get R, C double bond O, just add another O in front of the H. Okay, just add another O in front of the H over here. Okay, if I can put it here. Okay, so you are going to get carboxylic acid. Okay, you are going to get carboxylic acid. So in a simple form, okay, or in a simple term, okay, how do I memorize this? How do I apply this? Okay, you can see this is one R group. So what I do, C and H, I put CH3. First thing, I put double bond O. And I know that this will not stop over there. So I need to put another O over there. The same thing to the right, okay, the same, okay, CH3, I put double bond O. It's an aldehyde. So this will not stop over there. I'll put O. And you compare, oh, this one and this one, they are the same. So how many product of oxidation? Only one, which is going to be CH3 double bond O, OH. This is the only product of oxidation. This is how you identify the product of oxidation. Okay, now, okay, if I put it in a, if let's say I want to just summarize everything. Okay, let's say I have C2H5, I have CH3, I have hydrogen, I have CH3. If I'm going to oxidize this with potassium manganate, acidified, and it is concentrated and it is going to be done under hot condition, what is the product that I will get? Okay, so this one is summarizing whatever things that I taught you. You break over here 2R groups. Okay, so 2R groups, just add the double bond O, just rewrite C2H5, rewrite CH3, that's it. When I look at the right hand side, okay, I will see that, oh, this one, there is 1R group. Okay, so what is going to happen? C double bond O, I put H, I put CH3, but it is not going to stop over there. There is going to be further oxidation. Put O in front of the H. This is going to be my product. So how many products that I will get if I write it down properly? C2H5, C double bond O, CH3, and C double bond O, okay, OH, and then CH3. So you have a ketone. This is a ketone, and this is carboxylic acid. So it depends on the molecule that you have over there. Thompson, can you understand this?
Yes. Yes.
Okay, in summary, if I have carbon double bond carbon, if I have R and R, if I have H and H, or if I have carbon double bond carbon, if I have RH, and then if I have R and R, for example, okay, if I break this, okay, I am going to get R, C, R double bond O, and then this one CHH, it's going to be carbon dioxide and water. If I have this, I am going to get double bond O, R, and then this H, but we will not stop over there. It will be further oxidation to give you carboxylic acid. This one is going to be, so double bond O, R, and R over there, so ketone. So you are going to get 2 products here, but you are going to get 3 products over here. The number of products, it depends on the type of alkene that you have. Okay, that is very important. Okay, so with